All right. So let's get started. So yesterday I was working on constructing my build.zig, converting over from a shell script. I was running into some issues. I think I got past them. The obj copies, I got the obj copy to work now. And now I need objdump to work. So if we look at build.sh, what we need here is objdump. What this does is it actually produces a disassembly.txt, which is a disassembly, and then it runs this utility that I created called parsesymbol utility, which generates a binary file which contains a bunch of symbols used for stack tracing. Ideally, actually, what I like to do is I wrote this utility in Zig. So ideally, what I like to do is actually just incorporate the code base for this into build.zig. So I wouldn't even need an external utility like this. But I think we'll iterate that. That will be a later iteration. We won't do that right now. So right now I need, I'm trying to get the objdump command to work, and the issue with objdump is that it does not have an output flag. And it seems, looking through build.zig in the standard library, it seems there is no way to put a redirect to a file from objdump from a command line. So what I'm going to have to do as a workaround is just do a bash-c, which will just run this command in a separate bash shell. So hopefully this works. So if we do bash -c, and then here, this will be just the objdump command string. What's wrong here? Oh, okay. So what this should do is actually just output the disassembly file. So what is the disassembly file? Yeah, disassembly.txt, and then the int binary, which is kernel.elf. Okay, so let's see if this works. Okay, and then let's go to zig cache bin, and then we have a disassembly.txt, so that worked. Let's just make sure that it looks okay. This looks good. Cool. Alright, so that worked. So that's good. So what's our next thing? So another thing, just so I remember, so I did run the NASM, so I did run the assembler, so we don't need to do that. And then, so the next thing is this parse symbol util. So we'll do const symbol util command, and then this is equal to add, this is equal to add system command, and actually we'll need to do an alloc print here as well, because this is located in the install path as well. Actually no, This is located in the bin path. So actually, no. So we can just concatenate them because it's a constant. So don't need to do any funny business with that. So so this is what did I call this? The bin path. And then bin path parse symbol util. And then this is disassembly.txt, and then we'll create a new thing called disassembly.bin. So yeah, disassembly file, or actually maybe we should text file just to be more specific here. So disassembly, and then we need the bin file. So this is a disassembly text file, and then this will be the disassembly bin file. Dot. Okay. So what are we doing here? So this actually should fail. So disassembly. So let's do a build.sh clean. So we'll just clean out the build folder. And then this should fail to compile actually. Or not. You know what? Wait. Is disassembly? Oh, it's in here. It's in the bootloader, which I didn't compile yet. Okay, cool. So actually, one thing I wanted to do, in the bootloader kernel, I just want to move this. Just move this up here. Yeah, actually, yeah. To capitalize this. So, yeah, we'll get to that. Actually, get to this. Hey Ben. Yeah. So the Zig build process, Zig has a build process built into the language, which lives in a file called build.zig, which has this entry point called build, and it I guess you can think of it. Yeah, it is a comp type function. It is run when zig build is run. And what this function does is it kind of just like sets up a bunch of different things. It doesn't. One of the subtle things that I didn't immediately realize, but this is what it does, is that it kind of sets up a chain of dependencies between different things called steps. And so some steps depend on other steps and whatever. And then after, so all this does is just sets up a chain of steps. And then after this function returns, then it runs the chain of steps after that. The way it's kind of originally I thought it was actually, you see exe.install, like I thought it was actually installing here, but no, it doesn't do that here. It just tells it to install it at this point. Or to actually create, I think it creates an install step, actually. That's what this does. Though one of the things I'm still a little bit confused about is the dependency on how steps depend on each other. Like if you want to run like system utility, like some like system programs, like you have to depend on the install step. I'm sorry, you have to the install step has to depend on the utility, even though you want it the other way around. You want the utility to depend on the install step, because the installer creates the binary, or puts it in the right place. So I'm a little bit confused on how this works, but yeah. System with. Yeah, I haven't really done too much CI stuff. So I don't know. This hasn't, like, I'm just trying this out, or I'm just starting with this. My only complaint so far is I don't fully understand how this works, and number two is it's not really documented right now, so a lot of it is just kind of trial and error, and then like reading the source code as best as I can. But yeah, but I don't know, like Jenkins and like the GitHub build system, like I'm really not familiar with that stuff, so I can't really speak to that. So the next thing is the parse symbol command. So we do this again. So this is obj copy, obj dump. Actually, let's just do this. Why is this? This should just be. And then we just do this. Same thing. And then this should create a bin file. But Ben, the main thing I'm trying to do with this is to actually speed up my compile time. So yesterday I said I did like from clean about 30 seconds. So I'm hoping that this is faster. If it's not, then I actually might just stick with the bash script. Unable to. Oh, file not file. Okay. Oh, you can see here. Yeah, slash here. do you think the speed up would come from? I think, number one, I'm invoking Zig multiple times here. In build.sh, I'm invoking Zig a couple times. One for the for compiling the C file, for compiling the kernel, and then also compiling the bootloader. So I'm hoping that I'm only invoking Zig once here. So I'm hoping that would actually save on some time here. And also this parse symbol util, this is written in Zig that I wrote, so I can actually incorporate that into build.zig as Zig code. So I don't need to actually have a utility here. So that did work. So let's do an ls, and it did create in a disassembly.bin. Cool. And so let's take a look. This looks reasonable. Cool. So okay, we have the parse symbol, we have the debug symbol stuff here. What is the next step here? Is I already did the obj copy. Yeah, I already did the obj copy, I think. Yeah, obj dump. Yeah, so that is okay. And then, yeah, so I have kernel.bin. Okay, good. So I think I fully compiled the kernel. Well, the thing that I don't have are these AVX flags, but I will get to them later. Actually, let me just leave a note in here. To do AVX. My initial thoughts majority after it started up, especially. Yeah, I mean, you might be right. Oh, it has to compile the Zig build.zig file as well. Yeah, I mean, you might be right. And if that turns out to be the case, then I probably we'll see how much. I mean, if it really doesn't, like, even if it shaves a couple of seconds off, like, that would be nice. I mean, if it really doesn't, or if it makes things long, like, I think if it's at least even, I'd probably still keep it, because I have, like, this utility, this parse symbol util in parse symbol util in written in Zig already. But yeah, I mean, then you have to compile that too, so maybe that will slow down. You're compiling that every time, I guess. So yeah, maybe it will make things slower. I mean, I hope not. But it's good to at least experiment, and at least see if this turns out to be a failure. Then it's a failure. But does this make the build cross-platform? Though, not yet. That's kind of, honestly, that would be that is a goal. My plan eventually is to have this run on ARM. I really do. The kernel is so, is so tied to AMD 64 architecture right now that it's not feasible right now without any sort of real work, especially, you know, virtual memory and stuff like that. But you know, I even have, you know, AMD 64 specific stuff for, you know, spinning up threads and spinning up the cores and you know, all the interrupt stuff. And hell, even the keyboard driver is dependent on PS2, which is exclusively AMD 64 here. So, give me 1 second. So, the next thing here is what's the next thing? Next thing is to actually compile the bootloader. So we compile the kernel, and then we create a new executable, which is EFI. Oh, I first do like this make dir stuff. Let's not do that yet. Let's do this. All right, so this is the kernel, and now this will be the UEFI bootloader. So this will be add executable. This will be, oh, what do I call it? I call it oh, I invoked NASM again here. That's unnecessary. Though, actually, no, what? It is necessary because this compiles it using a Win64 format. So I need to invoke NASM again anyway. Alright. What do I call it? I call it boot64. How do I run this, by the way? Okay. Hell, I can probably, actually, you know what? I can probably do this. And then this should at least, whoops. So this will be UEFI bootloader. And then, yeah, that's what's called. So we add the UEFI bootloader, and then we also will do very similar things here. Actually, you know what? We can just bring this outside. And then we can do nasm command, and instead of elf 64, this will be win64. Is that what it is? Yeah. And then yeah, similar to this. So here we need to set the target. Yeah, we set the target in the build mode. So target is different. So here we have cross target is different here because this is the EFI target. So this is UEFI target. And then this is x86 Windows GNU. I don't know why it's GNU, but whatever. I think this is like kind of ignored, and I just like used it because Windows has its own calling convention. So I think this like overrides whatever this is. Okay. Cross target, then this is the UEFI cross target. UEFI. Okay. So, all right, so what's next? All right, so we have the target. That's correct. We need to add in the bridge.c file, which is here. And then we also need to add the the object file. For ASM. Okay. And then yeah, exe step. Yeah, this depends on the assembly step. And is that it? So C file, assembly file, UEFI file. I think that's it. Cool. And then this, and then also what we need to do is actually the ASM command step dot depend on, it depends on actually the this step. So this is the kernel exe. So let me actually kernel. All right, so I need to kind of rename this exe to kernel exe gc. Okay. All right, and then line 100. Oh yeah, depend on kernel exe.step. Okay. All right, so I think we got this. Let's run it. Okay. Options declared twice. Oh. That's why. So, okay, what is this return then? Standard target options. This returns a cross target. Wait. What? Wait, why am I doing this then? Just do that. Okay. Invalid name. It looks like a file path, but it's supposed to be the library application name. Oh, okay. So you can't really... Okay, so you can't really stick a path here. So I assume you probably need to like set like the install path or something like that. Okay. So let's see if this works. All right, that didn't do anything. Oh, I didn't do the exe.install. That's why. All right, so okay, that makes sense. We'll just do disassembly.bin. So it's in the same directory. Oh, okay, I see. Wait, so what do I do? What did I do here? Oh, I did like the zig cache. So that would be good if there was like a way of like injecting this path instead of hard coding it. Okay. Okay, cool. Though it says boot. It says .exe, which is not what I want. Oh! Wait, what is Windows then? Oh no, it's supposed to be this. This is it. Let's do that. It's supposed to be this. Clang found So okay. I'm guessing that means I have to do it the way that I have it in my build script, which is to create an object and then link it. That's a little unfortunate. 1 second. Alright. Alright, well, let's do that then, I guess. What is this called? This is called add executable. Is there like add object or something like that? You know, I think you can do. I think you can. I think you can do this. Add executable. So you might be able to do this. And then maybe this creates like a bridge.o or something like that. Yeah, regardless, this needs to be a new object file. Well, there is an add assembly, but I think the file... There's an add assembly file. That's interesting. But I think this probably doesn't support NASM. This probably supports AT&T syntax, which is always unfortunate, but Yeah, but maybe I'll look into that, because that would be interesting. Actually, you know what? Let me see here. What if I did do that? If we do, yeah, because then this depends on that. It's kind of annoying a little bit, actually. Then you have to like change it around. Alright. Let's not focus on that. Alright, so what we need to do is create now a separate C.obj file. And then this is going to be another executable. And then this is, this will be bridge.o. And then this will be bridge.c. So we'll get rid of this. And then this is the UEFI cross target, and then this is the Windows cross target, and then this is, I think, Windows GNU. Yeah, because I think like Zig doesn't like support, like there's a bug here where it doesn't like recognize, it compiles it differently, even though it should link the same because they're both the same. I think what was the error? The error was, oh yeah, unsupported option FPIC, which doesn't make sense here, I don't think, because like I thought like position independent, I thought this flag only like applies to like ELF files. Like I don't think it applies to like UEFI. So yeah. So this is the Windows cross target, right? And then so C.obj, and then what we do here is C.obj is as a command depend on kernel exe step. That's fine. And then C.obj is we set the so C.obj. This depends on the asm command step, but then this depends on the C.obj step. Right. And then we will set the target and then install C.obj, and then this is the Windows cross target, build mode, and then we do C. Okay, subsystem must be defined. Okay, so I think what we need to do here, and then what we do here is we add a C file here. So C source file, and then C, and then this is -C, because what was the error? Subsystem, like, no. Why do I need to define a subsystem? I'm not creating an application. I'm just compiling a C file. Is there what? Maybe exe is the wrong thing. Exe is possibly the wrong thing. Maybe there's like add object file, but like okay. Wait, maybe this is what we want. Lib exe obj step. So maybe we do want, hold on. All right, maybe it's not add executable, it's add object. Yeah, add object file. Or is it, wait, what was it called again? Add object. So we're just adding the object, which is, this will be bridge.o, and then this will be bridge.c. Then let's try that. Okay, wait. So then do we do exe.add object like, how do I just specify? So I'm trying to figure out how do you, can you add like an object step or something like that to an executable? So like we can, all right, so this would be the name of the object and then the root source, and then I see. I think and then we do add object file, which is bridge.o. Will that work? File not found. I'm guessing because it can't find bridge.o. Oh yeah, that's why. It doesn't tell me that it can't find bridge.o. I'm just assuming that it is, but it looks, that's the wrong path. That's not the right path. So actually, is there a way to So that means that this would be like zig cache or whatever. But actually, so that means our C obj step or C so do I need to do one of these? So asm obj, like, do I need to do one of these? So this will be C obj name or C obj path, and then this will be bridge.o. Honestly, this all right, so let's take a look here. File not found. But there is no cobj.install. That's not a thing. Yeah, it's not a thing. So how do I make sure? I mean, the exe, this depends on the cobj step. So I'm hoping, right? So if we do an ls of that, we do not see a bridge.o, which we should. Is there like an emit like function or something? Oh, maybe install artifact? No, that's what that does. Install raw. So how do I wait. Self. Wait, I'm just like, okay, all right. So this is the lib. I'm getting confused because this is just. Okay, this is just builder. Like, Yeah, build, add object. Seems right. Maybe you can remove the exe's temporary Oh, okay. Yeah, that's a good idea. Nope. It's not outputting it. So there must be some magic function to call that outputs it. Because install is definitely not it. Actually, so if we do make, yeah, so if we install artifact step, so it's basically saying no, this like obj is not a thing. Like you can't install an obj. So how do you output it then? Unless you're not like maybe add object file is the wrong thing. Maybe I'm supposed, is there a way to just add the object step itself? If we go back, I think I just looked for that, but let's see. Add object. Yeah, no, this is what I'm using now. Add object file. Oh. This might be it. Wait, did I try this? Alright, so that did work. Yeah, I feel you. I actually really I'm seeing what you're seeing because I really have very little experience with like CI systems and stuff like that. But I see what you mean with like the dependency graph and stuff like that. It can get real. It seems it can get really hairy pretty quickly here. Yeah, zig cache directory. That's where everything is. So this did work. And it did actually output an EFI file. And if we do, what is it, read PE zig cache and then look, let's pipe this to less. Does this say UEFI or UEFI anywhere? Image subsystem EFI application. Okay. But if we do this exe business, this is actual executable image. So, all right. So I think we got that working actually. So actually we can get rid of that. Let's remove zig cache. Let's build it. Alright, so we have everything here. We have boot.exe, UEFI. Okay. Let's see. Okay, so now time for the test. So we have it compiled now, right? So let's remove it, and now let's time it. This is the debug build. All right, so what is the debug build here? Holy crap. That's not good. But then if we remove, so if we have build, clean, right? And then, and then we do this. Oh, this is not going to work because I changed everything. All right. You know what? Let's do this then. Let's run zig build. All right, let's do this. Let's do build sh clean, and then we'll just do a zig build, which will only create the zig cache directory. For instance, it's just to write arbitrary function to have robust caching and to use language concurrency features if I want to parallelize things. Yeah, with the dependency system, you really can't parallelize things like this. Though I guess in theory you can. I mean, there are ways to do it if they're not dependent on each other. But yeah, like kind of like make. But do you is your preferred system is just a simple by arbitrary function you mean like a simple like script function like in Bash? Okay, so now we have the zig cache already there. So if we actually do a build, if we do a time, it is a lot faster. Huh. Why is that so much faster? Oh, because it has to do one more step as... Yeah, yeah, let me write a script in the target language. Yeah, I know what you mean. Yeah. Yeah, I'm like starting to think that this is probably not a good way to go. Why is it so much slower? Because it has to compile the build.zig? Is that why it's so much slower? But like 20 seconds? Like that doesn't make any sense to me. And this is doing more work. This is actually invoking zig build in here. Like, it's going through the apps, which I haven't even done yet. I haven't even compiled the apps that are supposed to be there. Well, at least it's a good experiment. This is like a good thing to learn from, at least. Like, I'm kind of baffled that it's so much slower. But well, the incremental build time. So all right, so we created the cache, right? So let's change something small, and let's just say here's a comment, right? And then we'll do that. All right, so that's 8.42 seconds. Now, here is another comment. And then let's do time build.sh. All right, so this is reasonable. I mean, I was hoping it would be faster than this, but at least it's in line with the other one. Okay, this is slightly slower now. Okay. Alright, that's interesting. Time to printf the current time. Yeah, I think there was something in the cache that was not built. Like, now I'm seeing more reasonable numbers. If I change, now I'm seeing more reasonable numbers, which is good. So if now let's change another comment in UEFI, and then let's compare this. All right, so that's 5 seconds because I think this is simpler. This is a simpler amount of code. And then let's do this. Another, or whatever. All right, so that's build.zig. So let's compile this. Now this is slower because now we're compiling build.zig. That's unfortunate. Our build.sh and zig builds sharing a cache. Yeah, no, they are sharing a cache. Yeah, no, there is. That's okay. That's I'm kind of now comparing like incremental builds right now. And so what I'm seeing now is that because it needs to compile build.zig, it runs twice when in the bash script it would only run once, or at least it would only compile once. Which slows down compile times. Now what I haven't done is release build. So let's try that, shall we? So already not looking too good. It seems if I let's try the kernel one more time. So let me get rid of this, and then let's just rebuild it with removing those comments. How long roughly? I actually haven't tested this. Actually, we can test this on stream. This is actually pretty easy to do. But you know what? I'm actually curious about that, just to have that in mind. Make their new zig proj, and then new zig proj, and then what is it? Zig init exe, and then zig build. So let's time this. So that's 7 seconds. And that's debug build, which is not fun. If you see zig build. Cannot type. Yeah, and this is a hello world. Yeah, the compile time is pretty slow with that. But yeah, so that's good to know. Why was the release build so much faster? I didn't do release. That was all debug. You mean when I ran it? Because when I run it, that's not release. That's not release. It just uses the cached version. So actually, let's do release then, right? This is actually a good experiment. So if we do zig build, yeah, it was just running the build.exe. So actually, good experiment is zig build. Wait, all right. So how do I help? It's all right. Release. So let's do release fast. So zig build release fast true run. That didn't do anything. Why didn't that do anything? So why is this not running? Do I need to put it here? No. Wait, hold on. Let me make sure if is it actually building the release, or looks like it's not changing it. Actually, this is kind of important to know how to compile the all right, 459K, And then if we do this, oops. That doesn't do anything. Oh, it does change it. Wait, really? So if I get rid of this, so does it not? So it's like ignoring the run, which is unfortunate. But so this, all right. So this actually does do something. Okay, that's interesting. So does it just like cough out a release? Like it's like blazing fast to create a release build somehow. Does it cache everything? Like when you run zig.build, does it also cache the release and it just outputs it immediately? No, the info, yeah, it's just not running. It's just ignoring this for some reason. No, like it works. It's just ignore it. When I put the dash release, it just like ignores this. I don't know why. But that's interesting. So if that's the case, then if we go to OSProj, and then we should do zig build the actually just make sure that we're all up to date. We are, and then all right, so if we do lsltr zig cache bin, all right, we'll see that all this stuff calculator, we only care about this thing. So so this is let's do human readable. I think it's 20 something megabytes, 24 megabytes. So now if we do zig build the release fast equals true, does something. So is it caching this? Oh, what's going on here? I don't know if this is... I'm sorry to think this is probably not what I'm going... I'm probably going to abandon this. This doesn't... There's something wrong here, I think. So now if we look at here, this is 10 megabytes. Okay, so it actually did something at least. Now if I run zig build again, which is debug build, all right, and then we go here, it switches to debug. And then now when I do release, okay, so now the release is cached. So now, okay, so, but, right, so once, so let's try this, right? So let's say I make a change here. I'll get rid of these comments. And then we just build our debug, right? Which is, I guess, about 8 seconds. And then we switch it to here, right? And let's time it. So it does more, right? So it only caches when you switch back and forth between them without changing any code. So looking 2 models of different triple. I mean, that is, you know, actually this does make sense. I mean, we are, but I don't know what is herd, like a new herd. Why is it picking that? Oh, kernel.elf is unknown. That's fine. It's freestanding. Whereas LD, I don't know what LD temp is. Almost a minute just to compile the 51 seconds to compile the release version. This trying to understand where the bottlenecks are. It's kind of odd to me. Is there a way to yes, it is enough to just delete the Zig cache folder. Correct. So this is telling me that I probably should just stick with the bash file. Seems like yeah. So in order to run it locally, it would be just Zig. It's actually so. What's nice about Zig is actually really easy to do this. Zig init exe and then Zig, and then Zig build, and that's it. I mean, well, actually, make dir, you have to make a directory, cd into it, and it, you know, make dir, blah, cd, blah, Zig init exe, and then Zig build. And then that compiles the debug version of the default program. Assuming you are on the master branch, I don't know. I think 7.1 also has this flow too. I think this also works with 7.1 as well. And then you can so it depends how you're invoking it, right? Like, I think what you have to do is, what I do? Zig. What did I call it again? Crap. What did I call it? New Zig project. And then you have to do Zig build d release fast true. That will set it to release fast, and then you do Zig build run. Like, you have to do this in 2 different commands, which I don't understand why, but that's what you have to do. It ignores this for some reason. I don't know why. It's the exe is in a Zig cache bin. So that's the exe. And you can even see this. So if you, what I was showing before is if you see this, wait, actually, so if I do Zig build release fast true, oh wait, and then I do here, so that's 8 kilobytes. So, but then wait, if I do Zig, No, I think I'm wrong. I think this doesn't... I think you have to manually invoke this. So if I do zig run and then do here, it just reverted back to debug build. Okay, so you switch back here and then you have to go zig cache bin new zig. Oh, and you're right. It seems optimize the print statement out. Why? Wait, what's going on? No, you're right. But if I do... Hold on. Hold the phone. Yeah, then that works. The help CCK. Oh! Stupid. I knew there was like a permutation I didn't try. But then if I set this to false, okay. But why does it optimize? Oh, you know what? Okay. I know why. Because this call only compiles in debug mode, because this is a standard log. Log only compiles in debug mode. That's just how it's programmed. That's for I guess there's different log levels and stuff like that. Yeah, no, it makes sense. I just realized that it's intended. It's not a bug. It's not a bug. It's a feature. But I think there is a debug print, which I don't know. There are ways of doing it in release mode, I would assume, at least. But yeah. Actually, I think I have to cut it off now. I have to bake some bread. So thank you for coming out. Thank you guys. Thanks, Ben. This is pretty informative. I think going forward for now, because of the much longer build times, I think I'm going to stick with using a bash script for now, at least. Play with this myself. All right, awesome. Yeah, I love to see what you hear what you find. So yeah, definitely let me know. So yeah, thanks guys. I'll probably stream definitely. I don't think again definitely this weekend. Pretty sure this weekend. All right. So yeah, thanks guys. And till next time.